Let's see. What is up, everybody? I had to cancel the last stream midway because I couldn't figure out the settings. Let's see here. Feel free to join the chat. Let's see what else here. All right. Okay. There we go. Okay, so just to give everybody a little rundown of what we did. First, we made this sketch. Right here, I just took some measurements off of the nozzle. And then we made this round sketch, and then we sweeped it. And then we made the same thing here, and then I shelled it. So pretty easy, but took about 2 minutes. Hopefully you guys can use your imagination. This is where we're at right now. I'm going to save it. Just going to right to the desktop. I'm creating a new folder. I don't know if you can see that. On my desktop. Probably not. Alright, so now it's saved. I'm going to go to Tools, go to Add-ins, make sure I got Flow Simulation turned on. Okay. So now I'm going to do a couple other things to make this a little bit easier on myself. I want to put it underwater, and I'm going to do it all in the same scene right here. I'm going to just basically set it like this. We're going to create a new sketch here. Let's just say that the ground is about this far. Let's say an inch away. Yeah, about an inch. Okay, so we got an inch away from the ground. And then I want to also make it go kind of up, because we've got to go up the water and then up into the nozzle or the flow or the into the sluice box or the dredge box. So we're going to go this way, and we're going to go up a few feet, and we go over. And let's say, I don't know, let's say the water is here. Let's say we're 48 inches, 4 feet underwater, right? Yeah. And we gotta go. Now let's just say that this is an easier target. Let's say this is like 2 feet underwater. Okay, and then let's say that the dredge box is floating on the water. Oh, I don't know. Something like that. There's the pontoons. Let's say they're 6 inches. Let's say they're 24 inches long, so 2 feet. Yeah, that's still pretty small. Okay, and now I'm gonna put a let's just say we're gonna put a box in here somewhere. Let's go like boom, 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 and this, I'm gonna say that this is a 8-degree angle. And so we want it above the water for sure. It's my box. Let's say it's let's say this is 48 inches long. Still above the water, it looks like. Nope, we're not. We don't want to be below the water on the way out. So let's say this is 36 inches long. Okay, well, I'm gonna go get some more coffee. You guys digest all that. I'll be right back. Alright, that was quick. I've got the coffee on tap. Okay, so these are, let's just say this is like 8 inches. For now. Alright. I like that. I like that. Water. So we're going to connect all this stuff up. I like that. I'm going to take this line. I'm going to make it parallel with this thing. Doesn't probably matter. I'm gonna connect these there little dots. Okay. I gotta fix some stuff here. Just gonna fix this point. Just so I don't move this stuff around. It doesn't want me to do that. How about this point? Yeah. I think it wants a dimension. Okay, so let's dimension it real fast. Let's say it's 48 inches away. Okay. And then I'm just gonna I'm gonna get this guy and this guy and this guy, and I'm going to, for construction, give me a nice spline, since you guys know how much I love splines. Yeah, that's what I'm gonna do. Do 2 points on the spline, boom, boom. Then I'm going to tangent. This curvature thing is really weird. Okay, I don't have the settings all set up on this computer, so I gotta kind of manually fudge this. There we go. That's kind of what I'm looking at. Just a little, what do I call it? Something like that. Okay, so we got kind of the basic geometry set up here. Yeah, most of this stuff's just reference geometry. So let's draw the box, and then we'll draw this. And then we'll draw the box, and then these pontoons just for show, and then we'll draw this. Okay, so I'm gonna create a new sketch on this line. And that guy. So, you know, I don't know if this would be a 4 or an 8. Let's go with an 8-inch box. Probably have to change this a little bit later for the flow rate, but for now, we'll do an 8-inch box. We'll quickly shell that guy. Take these sides off. Something like that. Just a El Cheapo box. Yeah. Before I do that, I'm gonna pimp it out a little bit. I don't know how pimp this is gonna look, but just gonna go in, crash all over this stuff. Anything else gonna fall down? It's already yonderly like. Alright, let's get that out of the way. Whatever. Let's get rid of this. Something like that. I don't know, maybe we'll make it like OSHA safe. Get rid of these sharp edges. You're right. Starting with that. Okay, alright. So now let's do the other one. Dredge pontoons. Okay, so I don't know if this is actually the real physics, but you know, just gonna go 6. Okay, that looks pretty good. That looks pretty good. Okay, that's good. I'm gonna mirror that dog on that plane. All right. Body. Okay. Now we're looking like a little bit of a dredge setup. Enough to get the physics in there. You know, before I do all that, let's hide all this stuff for a second. We're gonna OSHA approve this, make it look like a real pontoon. Something like that. Whatever. Good enough. And then maybe like nice smooth edges here. Oh yeah. Kool-Aid guy just burst through. He's excited about that. Cool. Oh, I got a chat. Mandy Brown. Hi, Mandy. Thanks. It's a work in progress. All right. Let's go back to the drawing. Okay. So then I want to make the old tubulator. Put that stuff back together. And I am going to sketch that guy. I'm going to take you. I'm going to copy it over. Boom. And then I'm going to go sketch onto this plane. Convert the entities. No. Convert the entities. Convert this entity. Alright. Keep on going. Now I'm going to sweep that dog. Profile. What's this? Profile. Path. See if that works. There we go. I like it. That's what I'm talking about. Do I want to merge that? No, I don't want to merge that. I want that a separate piece. Okay. Next. Now, I'm trying to figure out where am I going to put my pump. Now, since this is designed around a bilge pump, I'm actually going to put my pump in the water. Somewhere, let's just say it's like over here on the ground. So we'll draw the pump next. Let's go back to my original sketch that's got all the science in there. Where all my dimensions are. So I'm gonna rough in a pump. Sitting on the ground, under here. And then it's probably got one of those fancy outlets around here. Sure, why not? So apparently this dimension though is 2 inches. According to the manual. The 47 GPH pump. Alright, so that's what we're going to call the pump. Yeah. So how am I going to make that real quick? Fastest way for me to make that would be to jump out of the sketch. Okay, we're just going to real quick make a plane. Right there and at this point. Okay, then I'm going to make a circle. I'm going to sketch on that plane. Make a circle on it. Put it right in the middle. Come on. Select midpoint. There we go. Oh, no. Okay. Then also I want to use this to constrain it. And then I'm going to go up to here. Not merging any results. Okay, do the same thing with the other piece. Here, gonna get another plane. Put it here. Not gonna explain what I'm doing because it's just gonna be. It's not really what this is for. I'm gonna sketch on it. Circle. I'm sure somebody could do this a lot faster. Alrighty, okay, same thing here, get it to go to there, that way I can use the same information. Up to surface, boom, alright. So this is gonna be my pump. It's kind of corny, but it'll do. So now the next thing is this right here is, oh, it's not quite the right dimension. Let me measure real quick what he's got here. The inside is actually 0.12. So what's the thickness? 0.125 thick. What am I measuring here? Evaluate, measure. What do we got going on here? Diameter 0.6. Okay, so we need to open that up a bit. So what's constraining this shell? Okay, so I'm going to cheat. Don't tell my engineering manager that I'm doing this. Just going to go ahead and open this face up. Direct edit, move face. Right here, boom, 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 boom. Alright, we're going to offset. I'm going to go. What was it? 1 verse. 1, 2. That's better. That's about what it's got. It's pretty thin. And then it gets actually a little bit narrower, even from here. But we're not going to put that in there. Let's try to keep this simple. Alright, we're going to go from here now to here. It's a big difference. So ideally, we're going to want to do the adapter over here so that the pipe length can, the length of hose is the largest diameter so that it doesn't have any drag or resistance and flow. So I'm going to get it all the way up to like here, and then I'm gonna reduce it down. Okay, that makes sense, everybody? If not, clear as mud. Okay, perfect. We're gonna go here, offset this. I want like a good 4 inches. Oh man, we're on the plane here. What we got going on here? Okay. So I'm gonna put a plane there, put another plane, and then when I make it 4 inches away, 4 inches. Jeez. Okay, we're gonna go to like, the way that this geometry works is we're gonna be running out of space. So let's make it 2 inches. What? Where'd you go? It's the wrong button. 2 inches. There we go. Man. Doesn't leave us much room there, does it? To get around. We gotta get around this thing. Oh man, this is getting complicated. So it's gonna be 1 inch. 1 inch reducer. Okay, we're gonna do it. So we're gonna go from here. Let's go back on this. So we're gonna have to do a 3D sketch. Ooh, fancy. 3D sketch. Not many people know how to do this, but I do. Been doing it for a long time. All right. I gotta go in the options, change tools, options. I didn't think I'd have to set this computer up, but I am going to document. Let's see here, spline. I don't know if you can see this. There it is. Enable spline tangencies. That's what we're talking about. Okay, so now I click on this. I should be able to see these little handles right here. Where are they? There it is, right there. There. That's exactly what we're looking for. So this guy, that little line, and I'm going to get some more geometry to show up real quick. Where'd you go? Where's the other sweep? Oh, way up here. Man, I did a lot of geometry already. Where'd you go? Show. There we go. So now I can get this spline and this thing, and then I can go collinear. So then it's like in line with it. Same with this one. This handle, oh, I don't have anything over here on that sketch though. So I'm gonna have to jump out of this 3D sketch and go back into here. I'm gonna put a line in it. Okay, so we're back to the original sketch. Now we're gonna jump back to the 3D sketch. Go from here and here. That's the secret. What do we got going on here? This guy and this guy. Collinear. Okay, so now what are we gonna do here? So I'm gonna have to add a spline point. Insert spline point right there. I'm gonna have to look at it from the top. And I'm gonna move this spline point around it. Because we want to get around this hose, we gotta go around it. Alright, so I'll give myself some space. Like that. That's what we're talking about. Alright, here we go. Shoot. Okay, I'm going to go back in time before that spline existed, and I'm going to go on this sketch. I just realized that I need to be up here because I'm going to make the reducer right there. So you're going to move this point. Remove the references, the link it together. Put it right there. Make sure I click on it. So now, okay. Something like that. Alright, so now we're, what do you got going on here? That must have moved. Oh no, that's the other sketch. Okay, that's why it looks like that. I'm gonna hide it so we don't get confused anymore. So here is sweep action. So we're gonna sweep that face along this. Oh, look at it touch. Look how big that is. We're gonna have to make a reducing fool out of this. That's annoying. Alright, let's go over to the top plane again. I'm going to move this even more. Hopefully this is super flexible stuff. Man, I don't know how we're going to get it out of there. I'm going to have to give myself some space or crank it over. There's just not much room. I could see why they're using smaller nozzles or smaller tubing. Well, I want to edit this. Sorry, Kyle. We're going to change your design a little bit. We don't need that much length. Ooh, that's kind of cool looking. What do we got there? Yeah, I'm going to just undo that. Where did we go wrong here? Let's get out of there. Use up all my undos. I'm gonna have to go with either a smaller tube or I just straight put this somewhere else. Why do you gotta be so annoying? Let's see, maybe the chat, maybe somebody's got some suggestions in the chat. Nope. Nobody has any suggestions. Okay, gonna go back here. Alright, so some of you who are just joining us, we're taking this Upmost Outdoors Dredge nozzle and we're going to do some fluid flow analysis on it. But first I got to get the physics and geometry at least close so that my assumptions are accurate. But right now I'm having an issue with this tube and this tube hitting each other. So I might have to take this guy and add a point to it too. I don't like doing this. Just oh, it won't let me do that because it's not even the right one. Since that was a copied one, I gotta go to the original. Where are you? Where did all that... Where was all that stuff? Where all those sketches were? No. 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 Where is that sketch? Alright, is he gonna tell me when it's on? Maybe the sketch is after. Sometimes it... There it is. Okay, so this guy... You gotta be real careful when you move this stuff. You gotta be exactly in the right view, or else it'll go all over the place. Can you give it to me? No? Ah, man. You see what I mean? Gotta look at it from the top plane. Well, the only other way I know how to do this is to use this guy, and then what I can do is I can tell it to go in this plane here, this direction. Oh, wait a minute. This isn't... Is this not a 3D sketch? That's why this isn't a 3D sketch. No wonder. Okay, so... that sucks. Alright, we're gonna leave this one alone. We're gonna go back to 3D sketch. This sweep right here. Well, this is gonna be kind of boring while I figure this out. Just to think. Let's go back. Let's just cheat. Before I get this guy. Okay, you're not supposed to tell the engineering manager I'm doing this. Some guys are just weird about how you format your CAD, but hey, if it works, it works. I met a guy once, and he's actually at Roaring Camp. He's like, "You don't use move faces in your SolidWorks, do you?" Well, yeah, I use it all the time. I can't figure out people's CAD when they do that. That sucks, man. It's because you don't know how to use a feature tree. Whatever. I'm gonna move this thing like that. Hopefully that doesn't kill the geometry. So close. Alright, we're gonna have to do something else. We're gonna have to put a reducer in on this side, or over here somewhere. No wonder this isn't working so well for a lot of people. Well, this is bad. Alright, let's say there's a 1.5 inch hose. Like, ugh, that's terrible. That's terrible. That's a lot of volume. Okay, we're gonna go with a 1.5 inch hose. That's because that's what I'm seeing people using on the Facebook. And I don't want to mess with this anymore. Let's just get something set up. That's better. I'm going to take this point a little bit more. I'm going to look at it from this way though, so I only move it in the XY direction. This is getting kind of complicated looking. Oh wow, look at all that. Okay, hold on. Hold on. All that room. I want a 2 inch hose. I want it. That's what I want. You ever wanted something so bad, you just do it? I don't know what kind of reducer I'm going to put down there. You know, they do make angled reducers. Like a 45 that reduces down. Gosh, that's going to mess up the flow a lot. It probably doesn't need to be that drastic now that I look at it. So let's get it from the top view. I'm going to move it just a bit. Who would have thought I would have spent all this time on this little hose? Story of my life. Okay, that is better. Then we gotta get a reducer somehow. This is terrible. Whatever. I know that I can 3D print this, so this is all 3D printed. So boop, boop. There you go. That's it. Alrighty. Get to science. It's all scientifically accurate now, ish. Okay. That's better. With the water, let's put the water level in now. Like that. I don't think these pontoons are going to float like that, but we're going to just pretend they do. Let's check the chat, see if anybody's got any suggestions. Nope. Nobody's got any suggestions. Okay. Okay, we're hiding all this stuff. There's the bottom of the waterway. There's the water. Save this. Okay. Let's put this to be the ground. This will be our area of interest. Check the coordinate system. I like things to be like symmetrical. All right, that is the setup. So from here to here, that is going to be the head of water pushing down. From here to here is the head push that the pump has to push up. From here to here. Not much. But these little bilge pumps, they do not have a lot of pressure. They don't have any pressure at all. So we're gonna have to work with that. I'm gonna isolate this guy real quick, and I merged it. How did I merge this? We don't want to merge that. Okay, exit the isolate. Sure or not. What is going on with my keyboard? Yeah. This is the hardest .0625 I've ever in my life. Nobody on the chat anymore, so. I'm gonna take a little break, get some more coffee. Put the microphone down. Let everybody look at what's going on. Well, I've already pretty much cannibalized this design, but the physics is close. And so, well, to be honest, this to this is just pressure head pressure. So, I'm going to delete it. No, I'm going to split it. split. No, not one. Split. Right there. Yeah. We'll split that. Alright, what are you doing? Okay. Player selection. Just want that guy. Cut bodies. So, what do you want? You want this piece? Yeah. Consume? No. Okay. So now this body, so all this stuff right here is technically useless in the equations. We're only worried about this. We want to make sure that we can get the gold particles up this hose, and we're going to apply head pressure at this surface right here, right there, and I think the easiest way to do that is to create a surface on these ends. So it'll be, I'm going to cap all these guys off. Yeah, get rid of this stuff. And my pump's going to go. So this is really what we need to do the analysis on. And the floor. Where's that floor at? Okay, so let's just go to flow simulations. No, I'm just gonna make them myself. So make the caps. You'll see why I'm doing this here in a second. Hook the microphone back up to myself. These caps are just for the science, for the simulation. They're not actually going to be affecting the physics. It's just going to be where I place the boundary conditions. One more. I'm gonna do it here. Okay. Save her up. Alright, so I think we're ready to start doing some stuff. I want to get a measurement from here to here. Oh. Let's just say 10 inches. 10 inches head. That's the pressure we have to overcome due to gravity. And then let me look up real quick look up on my phone what the pump is rated at. It is a, 474700 GPH C-flow head pump curve. Okay, so $13 feet. Hold on, we got a curve here, so it's we've got, how many feet ahead did I say? About a foot ahead. Okay, so we've got to match the pump curve. So we only have a certain amount of energy that the pump produces. And this might be a little bit of an iterative process. So right now, let's just say that we're going to use the data point 6.5 feet ahead. Gives you 3,657 gallons per hour. That right there is 18.5 amps. 12 volt version. So do the math. 18.5 times 12. 222 watts of power. Okay. I like how people want to use batteries for these things because it gives them about 10 minutes worth of runtime. It would seem like 200 watts. Let's see, is that even a practical application? You could totally see why the P90 pump is a popular option for this. The power to weight ratio on gas, like fuel, is way, way better than any other source of energy. It's like a penny's worth of gasoline for 222 watts. Okay. But it's like a whole Ryobi battery in an hour. Yeah. Like an hour and a half, the 7 amp hour, maybe an hour, not even 45 minutes, 30 minutes. Okay. So now we're going to go into the actual simulation. Got a ton of things on my desk. It makes it hard to type. Pressure, we're gonna go with PSI. Yeah. All right. Inch squared, pound. I think that's pound force inch squared is PSI. Let me look that up real quick. Is pound force inch squared PSI? No, Google, tell me right now. Yes. Interesting. I never realized the nomenclature was pound force. So it's not just pounds, it's pound force per square inch. So that's what we're using. Feet per second. Yes, I like that. Mass, pounds. Sure. Length, feet, temperature, Fahrenheit, time, seconds. Now there's another one in here. Acceleration. Feet cubed per minute. So let's change this to what the pump's rated at. Gallon minute. Gallons per minute. Can I make it? Oh man. Let's just go with pounds per or gallons per minute. Okay, I guess we're gonna have to go with gallons per minute instead of gallons per hour. That's just gonna save a lot of time, heat, turbulence, inch, pound force, feet, yep, time, seconds, erosion, noise. We don't need any of that. Okay. We have gravity, and the gravity is in the negative x direction. So we're gonna go like this. Negative 32 point, come on keyboard, 2.1850394. 0. Now we're not going to use free service in this calculation. It's going to make it way more complicated. That's why we're going to use the assumption that this all is gone and we have a static pressure head right here. If not, we'd have to unclick that and draw in a bunch of extra stuff. Next, gases, liquids. We're going to add water. Yes, there's going to be cavitation. Turbulent and laminar. Yeah, that's gonna be there. These guys on Facebook. It's gonna wear out. Okay, yeah, sure it will. Default wall, thermal condition. Yeah, we're not gonna have any. I always use at least 60, if not more. That's for stainless. Let's go like 80. You can always change that. Thermodynamic parameters. Pressure. Yes. Yes, so we need standard pressure, ambient pressure, yes. temperature. Well, I had a guy yesterday in the chat tell me that the temperature outside is 160 degrees Fahrenheit. It's going to melt the nozzle if it's 3D printed. Should I put in 160 degrees Fahrenheit? No. We're just going to leave it right there. 68. That's fine. There's no velocity. We're going to pretend like there's no velocity going involved here. Okay, we're not going to account for the river flow rate or any of that. Look at that. Okay, close. So input data, component control. We don't want all this stuff in here. We don't need that. We want that. We don't want that. Get out of there. We want that. Don't think we want these little blocks. We don't want that. We want that one. Come on, where's the other split? There it is, okay. You're gone. You're gone. So we turned everything off. We got that on. We've got that on. Got that on. Got that on. We don't need that. So I got all these. Where's my little end caps? I want to make sure I got all the end caps here. We need that end cap. No, it's got to be off. End caps are off, I think. Might have to turn those on in a second. So we got that. We've got that. We've got that. Yeah, those are the components that we need to do. Oh no, so we do need those end caps. Okay. Alright, so now we're only looking at this as our subdomain. I'm going to get rid of the other features that we don't need to see. Just gonna look some stuff up. Let's see here. Well, I had a guy yesterday. I'm trying to look through the chat. Give me a second, whoever's watching. Okay, so let's set up some boundary conditions. Hide that guy. So, I got this guy. So we're going to turn him off for a second. So I can get to this face right here. Okay. So remember we were talking about the so right now it's saying that static pressure 14 pound force, but we need to add, what do we say? We need to add at least 1 foot of head. So I gotta figure what that is in pound force. Actually, let's just put all the head in there. So let's just go with 6.5 feet head to PSI equals. So plus 2.8 pound force more. 2.8. Oh, it won't give me that. Alright, so I have to do it on my calculator. 14.6959473 plus 2.28. 1 6.9756473. 16 pounds of pressure. Just gotta go up against that dog. And let's go to the other guy. Gotta do the other one here. Now this guy, it's an opening. And then, how far deep is that? Let's see. Do I add the water head to this? No, I don't think so. I might have to come back to that. I don't know if I add the water. I forget how this works. Yeah, I think that I'm going to keep the underwater reference point at... I'm going to keep the reference point at the water level. I'm about to change that once I look at the math. So the last one is this guy right here. This is the flow in. What did we say? We had... Oh boy. Okay, so we got to do it in mass flow rate. So 3657 GPH. I'm gonna see if Google will just translate this for me. So 3567 H water to LB second. Go. 8.2 pounds per second of water getting pumped through there. 8.2 pounds per second. Alrighty. 8 pounds of water. That's crazy. Let's get everything put back together here. Oh, Humpty Dumpty. Save it. All right. So what's left? So I've got all the boundary conditions. Oh, I gotta make a mesh. Global mesh. I'm just gonna mesh this whole thing. I don't know. Advanced. I mean, we want it pretty tight here. Okay, so smaller than that. Okay, so our basic mesh is gonna be. Oh man. Let's just do automatic. Let's see if we can get a couple different. Let's see if we do that. Create the mesh. We're not going to solve it. We're just going to use all the cores I got on this computer. We got a couple people looking. All right. Oh, you guys can't see this. Wow, it's fascinating. Okay, it's almost done. So what we're doing is we're solving a giant differential equation. It's kind of crazy to think about. Let's see what that looks like on this face. Failed. Oh man. Cut plot. Which plane am I on here? I want the mid plane. That one. Mesh, fixed color. Let's see, can you give me the mesh? I want to see what I'm looking at here. There we go. Alright, yeah, that's better. Okay, so we gotta cut this dog in half. So this is the mesh that we're gonna use. Let's see here how basic. This is super basic. The way that this works is that we had the boundary conditions, which we showed. Inlet, outlet, inlet, and then basically what it does is it applies that mathematically to these cells, and then basically runs the simulation, and this cell will adjust this cell, and this cell will adjust this cell all the way up till it gets to the other cells, and then all the cells basically have forces applied to them, and then they basically balance out the forces after a bunch of calculations. It goes around and around and around and around until each one of the cells are basically at equilibrium at this steady state. I know it's a lot of scientific words, but trust me, it works. The more fine this mesh is, the better scientific results we get. But I like to keep it really basic at first, just to get this geometry set up to make sure everything's looking good. So yeah, so then now I like that mesh. This is super clean, simple. There's not a bunch of weird wonky triangles in here, broken mesh. And so I don't know if you're going to be able to see this next step, but I am going to run Where is it at? Run the simulation right here. We don't need to mesh it anymore. We want all cores. We're going to load the previous processing after results. Okay, we're going to run that. And then there's going to be a screen that pops up on my computer. I don't think you're going to be able to see it. And it's going to do this for a long time. I don't know how long. Let's go back to the chat, see if there's anybody even there. Alright, we got one person. It's probably me. What's up, self? If there's anybody in the chat, let me know. Alright, so it's just running the simulation right now. It's on iteration number 22. I wish there was a way to speed this up, but I'm going to take a break. I don't know if anybody's even going to be watching this part, so we'll come back with the results here in about, I don't know, might take 5 minutes. We'll see. Let's see if I can get another window to show up. Nope, it won't show the window that I'm looking at. So you guys can't see what I'm looking at, I'm sorry. What plane was that? Top plane, alright. You. Okay. Alright. It's doing what it's supposed to do. It is not changing much. just gonna let it go a few more. It looks like the calculation's stabilized out, balancing out here. Yeah, I think I gotta go and change that inlet pressure because it goes up. So,
In like an hour, we're gonna go to Florida and work out. Or do some football jokes, okay?
hello. Okay, let's see here. All right. Can you guys still hear me? Hello? Hello? Yep. Oh yeah, there's definitely an echo now. Alright, I want to stop calculations. Alright. Alright, so let's look at the results. Okay. Alright, this is the boring stuff. Insert flow trajectories on this plane right here. Go with velocity. Velocity. See what it does. See if it comes back out. No? Goes up. Alright, so it's having some issues here though. I think that's because I didn't put the right pressure. Yes. Okay, so let me fix the pressure here. I think it's this inlet pressure. I need to put underwater. How many feet did we say that was? 4 feet? Let's put that plane back on. Measure this real quick. From here. Here, what is that? 23, yeah, 23. Oh, lose an inch. Oh yeah, because it was inch up, okay. So 23 inches of head need to be added to here. Okay, let me ask Google what that is. .867 more psi. Alright, so 4.6 959. What did they say? .867. 15. This much. Update that pressure. Okay, now we're going to continue calculation. Run it some more. I don't think you guys are going to be able to see this. Continuing the calculation. So far, it's saying that this geometry doesn't work. It's saying that the nozzle doesn't create enough suction and it's coming out the front. So that's why I added the underwater pressure. There it goes. Balanced out. You can't see this, but I can read the information, the warnings and stuff. So we were able to get that to balance out. I don't know if you're gonna be able to get this thing any higher though. This is at the bare edge of actually working. I can see why this has not been a go-to design. Well, that's waiting. I think I can print this up a little bit. Some of this stuff looking in the way. No, not that one. Go ahead. I want this one. Let's look. We'll run it. I'll lift 50 iterations. Doesn't look like there's any changes happening. Looks pretty balanced. 47, 48, 9, 50. Alright, you want to stop calculation? Are you sure? Do you want to save? Yes. You can't see this. Okay, now we're going to look at the flow trajectories. Oh, there, now we got it. Oh, going up and in. Let's see, this is where it gets interesting. Okay, so it doesn't go very fast, that's for sure. Yeah. So what I'm sort of worried about right now, so the physics is good. Let's get this water inlet showing. So this is the water coming from the ground. I'm going to just make these a constant color. So the water coming from the ground is going to be from the river, under the lake, from the nozzle is going to be blue. And then water coming from this guy insert the water so we want to show that water from that face. gonna make this red. Okay. Alright, so this is kind of what's going on. There's this little eddy here. That's kind of killing it. What we can do is a particle study. So the way I do that is, oops, let's put a couple pieces of gold in here. So we'll do a new particle study. Let's call this particle study 1. Sure, why not? So it's a solid gold. Okay, and then the diameter of gold nugget, I'm just gonna say, I mean, we want to be able to pick a nugget up, right? Do we want nuggets, guys, or do you just like tiny gold? So let's say it's 0.1 of an inch in diameter. What is that in feet? Give me, come on, what is it in feet? I don't know what 0.1 is in feet. I'll have to convert it real quick. Calculator. Alright. So this is 0.00833333 feet. Okay. Okay. Let's say there's 5 nuggets in there. Gold. Alright. We're going to clone this. And we're going to call this magnetite. Edit this magnetite. Iron. Oh, there it is. Same size particles. Let's do another one. Let's call it sand. No. Glass, maybe? Quartz? Sure. We'll say it's quartz pieces. I'd say there's a lot more of those. 20 quartz pieces. It's about the, just using that as the density. It's not even super relevant. Just gonna get something heavy, medium, light. And then I'm gonna run this. Okay, so we're gonna back out, show you what we got here. There's the dredge. Blue's fresh water coming in, red is water from the pump. And so, sure. Let's just play it, see what happens. Oh, we got stuff dropping. Okay, hold on. We're gonna stop. Stop. Let me stop all. I go. So gold. Appearance, we're gonna make it a yellow ball. I don't know how this is. This is probably gonna be 5. Let's cut that in half. Let's see. I don't know. Okay, alright, I like that. I'm gonna make the magnetite ones black. The sand. Oh, like that color. Alright. Now let's run that dog. Yeah, see the black sand and blonde sand's dropping out in this guy. Yeah, it's not gonna work. You're just gonna be removing all the material. Yeah, it'll go up and over, but that's not gonna work. That is not gonna work, guys. It's not gonna work. Well, I don't know where to go with this. I can start changing the geometry, but I don't think this is gonna work. There's probably a little bit more science going on inside the nozzle that I'm not aware of, but when I look at it, it's actually going more towards, it looks like it's actually blasting a little bit towards the wall. So I can change that dimension. It looks like that this is actually blasting a little bit down towards this edge instead of the center line. So I'm going to stop this calculation here. And let's go back to this. Hide all this stuff. let's go back to the design here. Okay. So this, it looks like it's at an parallel. Somebody. Parallel to what? Parallel to, oh, that line. Yeah, we don't want it to be parallel. We're going to change the dimension. I'm going to change the angle a little bit. So that it angles a little bit down, like in the picture. So I gotta rerun all that simulation again. Oh, it doesn't look like things are happy here. I got to fix it. Oh, it looks like it comes out a little too far. So I gotta go to this line. Give me all kinds of errors. Alright, I know, I have to fix all that. Okay, so I got that angle down a little bit more. Down towards the bottom. So it has to cut through it. I don't know if that's going to make a difference, but we are going to try it. I got to redo the whole simulation though. I want to make sure the computational domain is still appropriate, but it is. New calculation, new mesh, this computer, boom. Okay, so it's going to be a second. Take a coffee break. It's going to be about 5 minutes. So whoever's watching, put your name in the chat. Let me know who you are. You might be a competitor of mine. Trying to keep your identity secret. Alright, I get it. I mean, still doesn't matter. You should just let me know who you are. I'm gonna go post this on Facebook, see if anybody wants to watch. Alright. it looks good. It's looking better. We have to. For some reason, it has way too much pressure. I'd say it's 68 psi right now, so I'm gonna have to turn down the pressure on the pump. Looks like we're getting back pressure from the system, so I gotta dial this back a little bit. The flow, so we're not getting that much flow, it looks like. Let's just say it did. We'll just leave it there for now. Okay, it's still doing stuff. Don't worry, guys. I didn't leave you. Gonna go grab some more coffee. This one's cold. Okay, it looks like the equation's pretty much balancing out on my end. So let's rerun it. Let's look at the pause, stop the calculation, stop it. Right. Okay, we're gonna go back. It's sucking it right up now. Okay, so it does look like that angle does change some stuff. It doesn't get past too far though. Okay, all right. I mean, there's still an eddy here. This does not want to cross this path for sure. I almost wonder if it would be better to have it lined up with this line and this line lined up.
Oh my coconut. Where's the dog at?
Okay, so, oh man, it's still not working. Yeah, see these guys. Let's see, actually, if They're with. You don't want it to absorb into the wall. There we go. It's working. Okay. Interesting. So the only problem with this is there's too much pressure. Which, look at the pressure. .53 psi. And the pump can only give us 6 feet ahead. What is that? I'm gonna go get my phone charger. So 6.5 feet head to PSI. It's 2.8 PSI. So we're way too much pressure. We're gonna have to turn down the flow rate quite a bit. So, just reduce the flow rate quite a bit. You guys can't see the screen. It's going to take like 5 minutes to rerun the simulation. I changed the pressure. So this nozzle would work perfectly with a P90 pump. We can definitely generate a lot more pressure at that flow rate. This bilge pump doesn't have that. Yeah, we're dropping quite a bit. We need to go way down though. Way down. Okay, I'm gonna be back in like 5 minutes. Oh, let me turn my microphone off. Hello. It looks like I didn't have the mic turned on for that last little section there after I got some snacks. What's going on here is that we need to balance out this pump power. And the last simulation, we dropped the flow. And then we're going to raise the flow and try to balance the flow to the pressure of the pump. And then look at the simulation right now. We've got the pump underpowered. Before we had it way overpowered. We had it basically what it needed to be, like a P90 pump. Gas powered with like 1.5, 2 horsepower. This 4700 GPH pump would be equivalent to, what did it say? Okay, so 13 feet, 2000, that's 22.6 amps times 12 volts. So 22.6 times 12 is a 271 watts, which is equal to, let me look at that in. So 271 watts to horsepower, 271 watts to horsepower. That is 0.363 horsepower. 0.363 horsepower. So that's a far cry from the gas pumps that have, I think it's 1 to, so I think the P90 is rated at, let me look at that real quick. So P90, I think that's a Keen pump curve. Performance. Am I even calling it the right thing? Yeah, it's a P90. Can't find the pump curve on it. Here it is. Okay, so they've got one horsepower at least. Where's the, is it? P90 pump size pounds. The P90 does 100 gallons per minute at 161 feet ahead. That's to compare that to the built pump that. So let's write those numbers right next to each other. 100 gallons per minute, so 6,000 gallons per hour, and it goes up to 161 feet ahead, which is over 10 times the power. That's insane. I don't know about this little pump, guys. Let me see what my math is on this. Okay, we're alright, we're starting to get Oh, we got the wrong one. 9. Okay, let me dial this in real quick. You guys can't see this. So we can't go over 13 psi. That's 5. So 5. So 5. So it's over 5 psi the whole place. I don't know. Just give me, man, this little pump's, I don't think this little pump's gonna do it. Fluid pressure 9. Yeah, this. I'm gonna have to open this up. Alright, doesn't look like we're changing much, so I'm gonna stop the calculation. Alright. $17 psi. We need this to be less than 5.629. Let's see what it's doing. I bet it's blowing back out. It might be working, but the pump can't make this. This is impossible for the pump to do. Let's see if if we can get a pump that does this. Let's see if it'll even pick up the iron and gold and stuff. No. Look at that. Gold's dropping right back down. That's not gonna work. Not even enough flow. Just gonna leave all the gold for the next guy. I love it. Maybe I should look for these little dredge nozzles and then go look for them. Look right underneath where the person was dredging. Come back with a more powerful pump. Right. Okay, so I'm gonna open this up. Looks like there's too much resistance here. I'm gonna see if I can't get it like bigger. I think that if we did that, we'll probably get better results. So this is definitely not the Upmost Nozzle anymore after this. I'm trying to figure out what makes that. Oh yeah, this. I'm gonna open up the diameter a bit. So right now it's a one inch. So I'm gonna go to, instead of 5, so that'll be 1.5. What? There it goes. Let me fix this. Okay. I'm gonna do a new calculation. You can't see this. I'm gonna rerun the calculation with this bigger pipe right here. Putting the mic down, gonna take a break. Yeah, we're still running the calculation, so there's not going to be much going on the screen as we're watching. That's still looking for a lot of pressure, that's for sure. I'm going to stop it. There we go. So 2 psi right here. We can go up some. So let's go back to the pump curve. We're going to have to iterate this. So the pump curve at 2 psi. So we gotta, let's bump this up a bit. 4. Let's bring this to 8. And that gives us, so 8 pounds per second. 8 is here. Actually, let's look on the pump curve first. So 13. We had lower half. That's 3,657 gallons per hour. Let's convert that. So I'm going to write that down real quick so I don't forget. So this number 2 is 6.56 feet. Goes to 3,657. So let's convert that. 3,657 gallons per hour to to pounds per second. So 8. Yeah, so 8.47. 8.47 pounds per hour. So, and then what's the PSI again? So let's change that to PSI. So we got 6.56 feet to PSI. Google is not helping right now. I was in the wrong button. It's 2.84 PSI. Okay. So 3.6. Okay, so we're getting closer. We could probably take 1 or 2 more times to find the exact pump flow rate. So I'm gonna run this. I'm just gonna do a new calculation. So we're gonna get all that old numbers in there. We're not gonna rerun the mesh.
Not bad.
This one looks like it's not good. Water must be coming out the front. No. It's dropping, so it might be balancing out. 0.19. I want it to be going the other way. It's not dropping much. Alright, I'm gonna leave it here. Stopping the calculation. We're not getting enough pressure difference. That's saying 6 psi now. The water is just going right out. Yeah, this 6 psi. Okay, so let's go back to the pump curve and see what 6 psi is. It's gonna, like I said, it's gonna take 2 or 3 iterations. It's 14 feet ahead. Okay, when is the... That's about 2,000. That's where we were before. So it's somewhere in between, let's say right in the middle. So we did 3,657 minus 2,000 divided by 2 plus 2,000. 2,828. Okay. 2,828. That's 9. Okay, so the next one we're going to do, that's 9.8 feet. It goes to 2,741. We're going to do that point. Okay. 2,741 GPH2 PSI 2 gallons per hour 2 pounds per second. That's 6.35, okay? There we go. We gotta run it again. This is what iteration means. I'm sure I could put like total power hydraulic head on the pump side, but I don't know, guys. I think I'm gonna have to cannibalize this 3D printed dredge nozzle. It's just not. It's just not a good idea to use a bilge pump. You just can't get the pressure. Now, either change it to a different pump. Can't get the physics to work on this pump at all. I could see why Kyle from Upmost is designing a new pump. I could change the height. I could change this height. I'm seeing guys in their videos with it like almost like flat. Not even a. I mean, this is like 0 slope. So maybe that's where I gotta go. Maybe I gotta make it so that it's like underwater. I was coming out the other side. Yes. I'm gonna stop it now. Let me see this. Yeah, let's stop it. See what that pressure looks like in that hose. So, gosh, I need to convert it over again. 9.8 psi. 9.8. Feet ahead. That should be, what did I say? 4 point, oh, here we go, 4.24 psi. Okay, so we got the, okay, so we've got this perfectly set up for the pump, at least. So we got this, the pump flow and the pressure set up exactly. So somehow we've got to make this work. Somehow. So I want to leave all this alone and maybe angle it. Let's see what this looks like. Let's see what these flow trajectories look like. That's coming out. Okay, so maybe I'm going to drop this down. I'm going to take this height down. Let's see. put it to static pressure, 14. Let's just see if we can get it up to the top of the water. Okay, I'm gonna rerun this simulation with this hose. It's gonna be questionable how high up out of the water we're gonna be taking this. And this is where it's gonna take a little while, so hang on. Give me like 5-10 minutes. Okay, we're starting to cross the threshold of it working. Somehow. Alright, I'm going to stop the calculation now. Looks like it's finished. Alright, let's check this. Let's check the pressure first. Ooh, wrong button. 3 is a little high. No, we had. What was it? What do we have on? I should have wrote that down. .24 psi. Okay. Okay, so we've got a little bit of pressure left. It's crazy to be only dealing with like 5 psi here. These bilge pumps aren't designed for pressure. Okay, so what do we got going on here? Let's see what the flow does. Oh yeah, that's looking good. See the red, we want it all. Okay, so everything's going out. So now we're looking, now this is actually within the realm. So I think a bilge pump could work as long as you don't go up very high here. That's what's killing us. It's coming out of the water this high. So we'll figure out how high here in a second. Let's see if this actually picks up the gold particles. Yeah, it's working. Barely working. Look at that. It's barely working. It's working though. And those are tenth of an inch. This is 1/10 of an inch gold pieces, but I mean, you want that. Okay, so I think I'm gonna call it quits here. Still not ideal. It's possible. You can see this stuff's just like sliding up the hose. If you had like a rigid hose, this would not work. So since we got a little bit more pressure here, we got about 1 more psi. I'm going to shrink the diameter of this to see if we can't get a little bit more velocity, but we got to be careful not to overdo it since we finally got the pump settings to work right. I mean, gosh, I would hate to be the guy who left all of his gold in his hose and he pulls it out of the water and all the gold slides down here. But I honestly think that the 2700 GPH pump is like barely enough. So I would recommend a bigger pump. They don't make another pump. I've done research. They actually make some pumps for clear water, but you have to have a screen on it and stuff. You might be better off using like a trash pump. Let's see. Let me see if I can get some trash pump parameters real quick. I was looking on Amazon. Oh, 48th Street, what's up? It's the bilge. I spelled bilge wrong, or whatever. What's up, 48th Street? Let me look on Amazon real fast, see if I can find a different pump. Yeah, so I was looking at this little submersible pump here. Here we go. So we gotta have at least 1 horsepower of power here. 1 horsepower. Give me 1 horsepower. So let me look at this other pump curve. Of course, they don't have pump curves on all these. Oh, here we go. So it does 20 feet ahead. So let's see what the flow rate is first before I pick the pump. Oh yeah, it was. I'm using 2,741 right now. Okay, so what is it on this pump? 20 feet. Okay, so I'm gonna put pump 2. And I'm gonna go to the middle of the curve. It goes, we want more flow. No, we want more pressure. Yeah, that's fine. So we're gonna go, so it's got 20 feet. 2,000 GPH. Okay, so we're going to leave our the mass flow rate about the same, and we're going to try to decrease the diameter of that. So 20 feet. That gives me 8.66 psi. Okay, so that gives me a lot more power. Okay, let's do that. Okay, so I want to decrease this diameter until we get to 8 psi. So we got way more pressure if we did that. Okay, so I'm gonna stop this, go here, go back to that. Close. So let's go back to the original size. Oh, change that. I'm gonna change this back to 1/2 inch. Messed up this thing. Okay, let's go back over to the flow simulation. Alright, now I gotta rerun the whole simulation again. More pressure, better pump. Alright. Oh, here we go. Give me 5 more minutes for it to run. A lot of science is happening over here. Don't have to get my hands dirty though. That's my favorite part. I see guys out there trying to test these things out in the field. There's this one guy with like a sled. He's getting water flow, but I don't know if he knows that the science isn't there. I mean, I give it to him for A for effort, that's for sure. But I mean, what do you do when you got limited resources? You just run with what you got. Everybody's trying to make a product for themselves. And this downloadable file makes 3D printed dredges more accessible. Let's see here, we're going to pressure 8 pound-feet. I think that's too much pressure. Oh, we're coming down. Reducing that by, let's see here, by 1/2 inch diameter makes a lot of pressure. A lot. I'm looking at it right now. I think we're looking at like 20 psi. Oh. I have to back it down. We want to be at 8 psi for that flow rate. We want to let for the calculation balance out. Can't believe it's already 3 o'clock here. Okay, we're balancing out. It's still looking like 20 psi though. Yeah, the problem with electric dredge. Oh, here we go. You need to change the U shape into a 45 angle with the pump in front of the nozzle. Yeah. A lot of pressure drop in this angle here. I'm trying to keep the dredge nozzle intact as much as I can because it's the Upmost Outfitters 3D printed dredge nozzle that's going around the internet. Yeah, I think ideally you could just bolt a pump right here, that electric pump. But the thing is that it needs more pressure. I like the idea of changing the geometry here so that we don't, oh, you can't see what I'm talking about. I like the idea of changing the geometry here here and here. Yeah, the U shape is killing the pressure. I'm sure it is. Yeah, for sure. I can just cut that off and just put the pressure opening right in front and let it go blast right into it. Let's just see what we get here with a different pump. Still. Stop the calculation. Ooh, right in there. 6. Oh, so we still got a little bit more. We got, what did I put? 8.66 psi. So we can go up a little bit more. A little bit more. Or make this a little smaller. So according to the pump curve, so what is 8.66? Let's do 10 feet. What is 10 feet? 10 feet ahead is 4 psi. So we can't go quite. Let's see here. What do we say here? 4 is 6. So write this next one down. So 10 feet is 4.33 psi. And that on the pump curve is, look, 3807. So I'm gonna go up some more. Flow here. Okay, look at this again. 3807 to 3807 gallons per hour. Water 2 pound per second equals. Eight pounds per second. Let's just hit it, even 8. Back to where we started. Basically exactly what we started the very first time. New calculation. Almost exactly the same physics as the very first run where we got it to work. It's just with a different pump. The other pump wasn't going to work. Oh. Let me go back to the chat, see if there's anybody chatting. Okay, 48th Street. Yeah. Good idea. I want to possibly mount the pump right to the nozzle. Be nice to put it right on the front, but I don't think that's a good idea to use that pump. Ugh. Yeah, the bilge pump would work if you're not coming out of the water very high. I think that's the issue. My original assumptions were just coming out of the water about a foot or so. There's just not enough power for that. Silt issue, yeah, mounting the pump near the nozzle will create silt issues. Yeah, it would. Definitely. Yeah, so it's probably not that good of an idea. Yeah, 48th Street. I see where you're going with that. This is like the most boring live stream ever. But it is what it is. Let's see what my math says. Stop the math. Looking good. Save the results. You guys can't see this, by the way. Oh, it says you need 6 to 10 hose diameters of straight coming from the 45 of the pump before it mixes at the throat. Okay, alright. So you're saying like 45 here and then a really long length of pipe this way? Ten PSI, what did I write down here? Oh, it went up too much. I went up too much on that one. What does the pump curve say at 10 PSI? 2000, so somewhere in between what I just had and what I just had. 8. This is telling me. Let's see if this actually works though. Let's figure out what pump that is. Okay, so that's working. 10 PSI, that's too much though. So this needs to be okay, so I'm gonna try that. I'm gonna try that from the sucking nozzle. You need 6 to 10 diameters of straight coming from the 45 of the pump from the suction nozzle before it mixes at the throat. Okay, 6 to 10 diameters. Okay, so let's change that. Let's just see. Let's see if we can't get it to work. So this is working. It's just gonna have to do a. Let's see right here real quick. Run. Let's see if we're picking up gold. No, not quite fast enough. It's dropping back down. Especially, I'm gonna show you. I'll hide this thing. Yeah, gold's sticking right there. Alright, I'm gonna try the old flip it around thing that 48th Street mentioned. So, let's take all this stuff away. And let's get rid of some of this stuff here. Let's get rid of this pump. Let's get rid of that. That. just gonna leave it straight. Let's just give it. Oh, let's make 45. Let's make it 45. So let's say it's a 1.5 inch, let's say 2-inch pipe, so 20 inches, right? That's what he said. What'd you say? You say 45. Okay, you need 6 to 10 hose diameter. So let's say 10, and the diameter is 2. That's 20 inches. That's above the water. Oh, great. No, that's not. I probably should put it in the other plane. Man, I need something else to tell it what to do. How do I need a plane that way? Let's keep it underwater. Close enough. I don't know what the standard radius is on a within that thing. Alright, let's go back to this. Oh, we still need to make a cap. Mm-hmm. Okay. Change the mass flow rate to here. Alright, so let's see, anything else? Get rid of the U and use a 45. Okay, so we good, okay. And so now our inlet, so we're gonna rerun that. Go to flow simulation. New calculation, new mesh, new everything. It looks like a weird dog leg, but you know, all in the name of science. Well, I don't know how much longer I got of this in me. Let me just check on my phone here what the rest of the world's got to say. Oh yeah, I don't have any programs on this phone. Oh yeah, what's going on here? Oh, there it goes. Alrighty. Alright, let's see if this is it. It's looking better on the computer screen that I see. You guys can't see it. Definitely see a low pressure system there. The 48th Street, how long have you been prospecting? I know you've been around for a while. What was it, like 2020 the first time I talked to you? A long time ago, 2019. I know you've been doing it for a while before that. Well, Kyle from Upmost, I hope you don't mind that I cannibalized the model a little bit. The name of science. My computer's making a lot of noise. It must be thinking pretty hard. I guess I'll just spin around the model a little bit while you guys wait. So this change right here was from 48th Street prospecting. So to have it come out at a 45, I couldn't have it go up because it was going to go up here. So I left it in this plane. We'll see. Let's see what the computer's saying right now. 21. Log. What's the log say? I'm going to let it go to 50 iterations. It looks like it's pretty stable now. Some more for good luck. Each program I use, the zoom's a different direction. I always have to do like an initial zoom in and zoom out. So I guess while you guys are looking, I could show you, well, open it. It won't. We're probably gonna break it. I better not try to open something. I'm gonna wait. I was gonna show you the new LDMA product that I'm making. It's the switchback with an LDMA logo on it. It's pretty neat. I already printed one off. Gonna go to all the new members. They're gonna get a brand new switchback. Let's see where this at. 28 still. Check the chat. Oh, here we go. You can adjust the straight to shorter if you need once you check how it's running. Okay. Yep. Oh, I kind of like it nice and long like that. It gives the water some momentum. The water hammer effect. You know what I'm saying? Okay. Let's see what we got going on here. Wish you guys can see this, but you can't. Okay, I'm going to stop this calculation, see where we're at right now. Boop. Finishing. Okay, finished. Pop over to the model here. Okay. So what do we need to edit this. One of these. This one. We need to isolate this real quick. We need to edit this dog so that the flow comes in from this one. Alright. Oh, it's coming out. A little water's coming out. We don't want that. What do we got? Why? Let's see what the other one shows. Oh man. I think I picked the wrong one. Oh well. These got switched, I think. Oh. What is going on here? What? These are some really weird results. Why is it going back up? Huh. Well, this is not what I'm expecting to see. Let me reset these. Just gonna delete them. Why would this? Be going out? This way. Huh. Let's see what the mesh looks like. It's higher pressure, lower pressure. Weird. I don't think I have this set up right. Something's up. It's not supposed to be going out the inlet hole. Well, I think that's all for today, guys. Yeah, I'm gonna end it now. Alright, everybody. See you later.